alumni of ISD.
I don't know very many alumni.
Oh, okay, I
necessarily,
see.
but I've
Okay,
never
I
met
see.
you, right?
I got my degree in 1994.
Oh, okay.
But I know Kermang, you know Kermang, right? Kermang.
Oh yeah, Kermang.
Okay.
Okay.
Dr. Free is my advisor.
advisor.
Was my
Oh, yeah.
advisor.
Oh,
A long,
yeah.
long time ago.
Long
Okay.
time ago.
So
So
I would leave my one of my PhD students, Ivan, with you in the system. Now I'm going to presentation hall to test the system over there. I think everything will be fine. I will let you know when you should start. So before you presentation, I will kind of introduce you to the audience, offline and online. Okay. So do you have any question to ask?
Are they going to advance the slides?
We're going to run the slides.
We're going to run the slides. Share our screen.
Pardon?
We're
You have to control your PPT.
各位来宾，大家早！今日上午的研讨会即将开始，敬请各位来宾师长就位。
还在楼下，我们都可以开始吗？好 ，OK， 好 ，OK， 可以开始。
专题演讲，邀请主持人国立台南大学林其贤教授。林教授，请。
OK， 好。Hi, good morning, everyone. I'm Qi Xianlin. I'm the chair of this keynote speaking session. Yeah, thank you for joining us. We have two speakers. They are in Indiana, Bloomington right now. You know, this is a kind of virtual presentation. The two speakers are Cindy Hmelo-Silver, and the other one is Krista Gretzky. It's a kind of German name, very difficult to pronounce. They are prominent professor in the field of inquiry-based learning and collaborative learning. Today, they are going to talk about the application of artificial intelligence, how to apply AI technology, nurture collaborative learning. It's quite a popular topic right now. So, ladies and gentlemen, would you please join us? Let's welcome two of them together. Thank you. So you are on now, right now.
Okay, well, thank you so much for your kind introduction. Oops.
I didn't get that. Could you try?
Siri's getting in the way as we try to get rid of.
And they are at the right now.
If we can get rid of the echo. Anyway, thank you for your kind introduction and for inviting us here this morning. It's evening here, so. So today, I just want to check that you can see our slides.
Yes.
Okay, great. Let me go back to the introduction. What I'm going to talk about today is artificial intelligence for scaffolding collaborative engagement in ambitious learning practices. Just to give you an overview of our talk, we'll start with providing some frameworks for thinking about ambitious learning practices and collaborative engagement. We'll talk a bit about our recently funded United States National Science Foundation Institute, Artificial Intelligence Institute for Engaged Student Learning. We'll talk a little bit about our showcase project of Eco Journeys and then about supporting educational equity. So let me start with a few definitions as I talk about a framework for ambitious learning practices. First, I want to define ambitious learning practices. And by those, we mean learning environments that are student-centered, collaborative, and require extended engagement with meaningful problems or questions. And we think about these because one of the things that we hope to promote is collaborative disciplinary engagement. And this kind of engagement goes beyond individual conceptions of engagement to consider engagement as collaborative and multidimensional. And it goes beyond thinking about time on task, but also considers the nature of collaborative interactions, the socio-emotional climate, metacognitive engagement, as well as how deeply learners are participating in disciplinary practices and using disciplinary concepts as tools for their problem solving and inquiry. These ambitious learning practices refer to the class of inquiry-based learning methods that engage learning in collaborative problem solving and reflect authenticity in the discipline, thus providing meaningful joint tasks and affording the kinds of collaborative disciplinary engagement I just mentioned. Some examples of these are case-based learning, problem-based learning, project-based learning, and the focus of our AI Institute on narrative-centered learning. As part of our work, we engage in participatory co-design to try and ensure that we develop learning environments that are relevant at a personal, local, and cultural level and promote a sense of belonging. We work with educators and learners throughout the design process to get input and feedback on our designs. We try to foster complex and consequential learning that reinforces learner agency, nurtures learner voice, and promotes learner authority. And here I speak to the notion of learner rather than just student, because we're considering learning as a lifelong, life-wide event that occurs in school, but also out of school. And we'll also talk about educators as well as teachers as we consider context both in and out of school. In our work, we try to leverage artificial intelligence that fosters meaningful collaboration, engagement, and learning by taking advantage of the productive and generative qualities of artificial intelligence that it enables us to adapt our work to particular populations and interests and provide adaptive support for collaboration, as well as providing meaningful context. In our work, we think of scaffolding as distributed, as we look at the interplay of facilitator and learner practices coupled with AI resources. We use these for structuring and managing the complexities of these learning environments, problematizing learning, and transferring responsibility to learners. But these kinds of learning environments are complex and require orchestration. So one of our goals is to help teachers and educators manage this and reduce the orchestration load as we help them work at the individual, group, and class levels. We try to do this by leveraging multimodal learning analytics in ways that are actionable for teachers and provide guidance and assistance to educators. The National Science Foundation AI Institute for Engaged Learning, the Engage AI Institute for short, has a focus on narrative-centered learning. Our institute will guide students through narrative-based lessons in science, technology, engineering, and mathematics. In other words, researchers will combine one of the newest technologies being applied to education with one of the oldest techniques, storytelling. As one of my co-investigators explains, how did people learn for 2,000 years? They told stories. We wanted to take something that is deeply embedded in what it means to be human and bring it back using artificial intelligence that can create stories and problems that are embedded in them. And by doing this, tap into something really fundamental about how people learn. The Engage AI Institute addresses several important challenges in education. These challenges reside in how we can develop narratives that will create problem contexts that will be relevant for learners and help them see STEM as addressing societal challenges they care about. We need to provide contexts that support extended engagement with important disciplinary content and practices. And again, these create learning environments with a lot of moving parts. So helping teachers manage or orchestrate these parts will be a priority. As an institute, we have two overarching educational research questions. One is, how can AI-driven narrative-centered learning environments support STEM learning and engagement during collaborative inquiry? And our second question focuses on, how do AI tools of embodied conversational agents and multimodal learning analytics help teachers manage collaborative inquiry in narrative-centered learning environments? And I'll say a little bit about some of our plans to address this. What I'd like to do now is describe the main thrusts of the Institute, and then Krista will describe an example of this in one of our showcase projects. Again, our three main thrusts are narrative-centered learning, embodied conversational agents, and multimodal learning analytics, but having these all deeply informed by considerations of ethics. Engage AI will create narrative-centered learning environments that generate engaging, interactive, story-based problem scenarios. To support interest-driven learning exploration, the learning environments will generate interactive narratives linked to authentic problem-solving scenarios with characters, behaviors and speech, curricular content, and adaptive support for collaborative learning. These will be dynamically tailored to serve the needs and interests of learners in specific contexts, such as classrooms and museums. We will create virtual, intelligent, embodied conversational agent technologies with multiple modalities for communication, such as speech, facial expression, gesture, gaze, and posture, to support engaging learning interactions. Embodied conversational agents will be driven by advances in natural language understanding and natural language generation, as well as computer vision and student modeling. I'd like to also point out we've got a great collaboration between educational researchers in learning sciences and instructional systems, as well as computer scientists. These agents will support a broad range of roles, including providing students with cognitive, motivational, and affective support, serving as virtual learning companions in collaborative learning, and serving as cognitive assistants to teachers. The Institute will create an innovative framework for multimodal learning analytics to support students, researchers, teachers, and informal STEM educators. It will greatly expand educator awareness of student activity in collaborative inquiry and support teacher orchestration. All of this will be informed by our cross-cutting research theme of artificial intelligence ethics and a concern for promoting diversity, equity, and inclusion. Our environments will be deeply informed by ethics considerations such as fairness, accountability, transparency, trust, and privacy. We'll promote diversity, equity, and inclusion through engaging diverse stakeholders throughout our design and development cycles, and produce story-centric problem scenarios that are socioculturally relevant and meaningful. Before we move on to talking specifically about eco-journeys, I just want to mention the Engage AI PI principal investigator team is James Lester of North Carolina State, Mohit Bansal of University of North Carolina, Gautam Biswas at Vanderbilt, and Jeremy Rochelle at Digital Promise, as well as our Indiana University team with my good colleague Krista Glazewski, and David Crandall, Joshua Danish, and Ann Leftwich. And Krista, you're on.
Great. So I want to take now a turn and talk about eco-journeys. Eco-journeys is a project that we've worked on for about 5 years now, and we're going to be showcasing eco-journeys as one of the main projects in the Engage AI Institute. The purpose of eco-journeys and the showcase of eco-journeys that I want to walk you through today is to show how students experience eco-journeys and how teachers facilitate within eco-journeys. And then I want to talk about the broader vision that we have and how it might be expanded in the AI Institute. So let me begin. Oh, I have to go over here. So eco-journeys is a web-based multiplayer game. We are targeting the middle school grades in the United States, and this is grades 6th, 7th, and 8th. So right before the students begin high school, and when they're still in this middle age range of playing games and still expecting lots of fun and engagement in their environment, and at the same time being able to engage with complex problem solving. Students are transported to a fictionalized island in the Philippines where the economy is driven by tilapia farming. They are enlisted by one of the scientists' sons to collect data that will help solve a mystery on the island. And this mystery is why the tilapia are dying at alarming rates. The cycle of inquiries for students is one in which they independently perform individual exploration and investigation in the environment, and then they gather with their team to collaboratively make sense of their investigations. And in doing so, they form inferences, explanations, and hypotheses and present an overall explanatory model of why the tilapia are dying at alarming rates and what can be done about it. The way that they encounter information and collect data is that they engage with, for example, non-playing characters. So here's Maria, a non-playing character who is explaining about cyanobacteria, which is one of the important components within the ecosystem. Another way that students collect information is by accessing other resources in the environment. So here, the student is being directed to take a look at Sulu's notebook on his desk, and then they can look at Sulu's notes, and then they can read about, in this case, abiotic and biotic factors in the environment. They can collect these notes into their own notebook, and those become usable in their collaboration tasks later. The other thing that students do is that they collect data in the environment, and they go to the different sites in the island, at the lab or at the hatcheries and on the fish ponds, and they collect water samples in the environment. And then here's an example of a student, the student character that's about to approach the hatchery. Now, what's happening here that I'm about to show you is another forms of support that is offered to the students. One of the important resources in EcoJourneys is the ongoing chat that they have with their teammates. So even while they're performing individual investigations, they can chat with their teammates and they can see what's going on. And students are in groups of 3 or 4 students. In this case, as the student is about to approach the hatchery, he can access the chat. And another character in the chat is the wizard. The wizard is an AI agent that is triggered where certain actions in the game can trigger the wizard to intervene or to ask a question. So in this case, the wizard is going to ask a question of the student. And as the student is approaching the hatchery, the student is triggered. This triggers an action in the chat, and the wizard asks the students, "Can someone tell me about respiration?" And then the student can answer. And the answer is about oxygen. This is important because as students are collecting water samples, they also are making sense of the complex and dynamic ecosystems. In other words, the system is queuing just-in-time information at a critical moment when the student needs to know it. When the students have collected all their water samples across the various sites in the island, they perform tests on those water samples, and then the results for those tests, that they collect the results from their tests, and then they look for patterns across the various tests. So together, collaboratively with their teammates, they make determinations and conclusions about the results of the test and the patterns that they see in the data. And this brings me to the main form of collaboration that the students engage with when they arrive at the collaboration board. So up until this point, in the investigation, the students been working primarily independently. When they've collected the data samples and they've taken all the notes that they need and they've looked for patterns across the data samples, they gather at the collaboration board. And there's 2 things that are happening at the collaboration board. The first thing that is happening is that the team has generated an explanation for why the water is cloudy. And so the team has determined, and they have generated an explanation that the water is cloudy because of organic matter. Once they have arrived at this type of explanation, every student on the team puts the notes on the board from their own notebook that are relevant to that explanation. And they either decide that this information is relevant and an idea that supports this explanation, or it's an idea that competes with that explanation, does not support that explanation. As a next stage in their investigation, what students do collaboratively is they talk about each note that is on the board. They click on the note, it pulls up more information and elaboration about the note, and every student votes whether or not it is relevant to the explanation, and then they vote if they agree that it supports the explanation or it does not support the explanation. So in this way, what they're doing is they're negotiating about their ideas and they're coordinating their joint efforts around the investigation and trying to build an explanatory model of why the tilapia are dying at such alarming rates. Now, for the teacher, this involves some complex facilitation work as well. And we envision and we talk about this as needing teacher facilitation and scaffolding on at least 3 planes. The individual supports that are required as a teacher's monitoring and working and supporting individuals. Small group supports, as again, the small group will have its own set of needs that are linked to individual needs, but they're also unique to that group as well. And then the whole class will need support. So this involves complex coordination and orchestration on the part of the teacher. So we're also envisioning an AI supports that can support teacher facilitation and orchestration. And the goal here really is to reduce demands on the teacher. So here's an example of a dashboard that the teacher encounters. And on the left are the groups that into each individual group. Then the teacher can see the progress of each individual group and where each group is located at this moment in time. Each individual group is given a participation score that the teacher can make sense of, and each group is also, the teacher receives information about the quality of scientific discussion for each group. So if we look more closely at Group H, we can see that the teacher is given vital information about Group H. There are 4 members in Group H. The participation is pretty balanced across all 4 members, but the scientific discussion is not very strong. Even though the students have finished the task where they are right this time, they have not provided accurate responses, and they've not been using what we're calling sentence starters to help support their explanations. And if the teacher requests more information, then the teacher can see the different questions that the students have responded to and how many correct responses that they've given. In this case, they've answered zero of the questions correctly. They've given no accurate responses. So we put this information at the fingertips of the teacher to support her individual facilitation and orchestration of the classroom. And the animating idea here is to make the different team work and work products visible and legible to the teacher. The other choice that the teacher has to do when she receives a notification is to decide how to respond. And one way that the teacher can respond is by pushing a message to the team in the chat. The teacher has the option of pushing messages to individual students or to the group or to the whole class. There are system recommended prompts that can happen. So in this case, the teacher is receiving an alert that there's unequal participation in group 2, and there's a pre-supplied prompt. The teacher could push this prompt out to the team. What are strategies we can use to make sure everyone is participating? Or the teacher can provide her own prompt. Maybe she wants to say something like that, but she wants to say it in her words. Hi, group 2, how are you encouraging participation from everyone? Now I want to take a step back, and I want to take stock of why we're doing what we're doing and what the motivating ideas are here. As a reminder, part of the animating idea behind Eco Journeys and the Engage AI Institute is a commitment to educational equity for a diverse range of learners. We assert that ambitious learning practices should be accessible to all learners, and we argue that AI technologies offer particularly innovative resources. But there are 2 key design moves that we're making to enable equity for all learners. The first is that we're prioritizing human-centered automation, and the second is that we're limiting labels deliberately. And I want to talk about each of these for a moment. We are prioritizing human-centered automation, and we're empowering the human in the loop. So what this means is that the teacher is the primary decision maker who engages the consequential pedagogical and scaffolding actions that are needed to support learners. We're placing focus on what is not automated here. We're placing focus on how the teacher decides what to say, to whom, and when. And we're freeing teacher time and enabling teacher action in this sense. And we're also limiting the labeling of the information as it comes to the teachers deliberately. So in other words, we are enabling expansive and contextually driven scaffolding. We're placing descriptive and informed comparative models in the hands of the teachers, but not diagnostic models. So in other words, we could very easily say that students or a group is off task, they're off track, they're slow, or that some groups are advanced, but we're not doing that. We're not letting the automation and the AI categorize, sort, and label. Instead, what we're doing is we're empowering the teacher to re-specify the norms and the goals in the environment, or even to abandon this idea altogether in favor of different ideas of progress and collaboration. And the reason we're doing this is because we're really imagining the scenario in which two very similar group profiles might require different sets of actions from the teachers. So we can imagine a group that's doing really well, they're marching through the tasks, they're all in agreement. Maybe they don't have a lot of scientific discussion going on, but for the most part, they are doing acceptably well of what's being asked of them in the environment. In some cases, depending on the group composition and who these students are, that would be a really good place for that student and the teacher doesn't need to intervene. In other instances, this might be a group that the teacher gives the teacher pause because she's noticing that they don't have a lot of rich scientific discussion going on. And she thinks that's not acceptable for this group. These are students, and she senses that maybe they're just not engaging right, or maybe they're being kind of lazy, or they're just marching through the task, but they're not really thinking about them. So she can go check in on that group. And so the animating idea here is that we really are empowering the teacher to be the human in the loop, making consequential pedagogical decisions about when to intervene and how to do it. So we really envision this as an ambitious learning, ideas for ambitious learning for all through technology design. We are driven by the idea that technology and generally and AI in specific can reduce the demands and it can support teachers, and we can avoid algorithmic biases and deficit conceptions of marginalized learners. This is an idea that people in our group have been working with for some time now, and you're welcome to check out one of the relevant papers that's listed here. So in summary, one of the main ideas and the main questions that we are really grappling with and trying to push forward is how we design educational technologies that make ambitious learning practices available and effective for all learners. We are doing so by leveraging the powers of artificial intelligence through AI-generated environments, AI-supported learning, and AI-supported orchestration. We invite you to connect with us after this, and we'll be happy to send you any of the papers associated with this work. Our emails are on the screen, and we also invite you to check out the websites for the AI Institute and for EcoJourneys, where you can get more information. Thank you so much.
Oh, hi. Thank you, Cindy and Christy. Thank you for your wonderful presentation. Yeah, we still have about 15 minutes for Q&A right now. Yeah, we are audience over here. Do you have any question you would like to ask our speaker? Yeah, otherwise I would like to raise one question first. Based on my perception, Krista and Cindy, I think you have a kind of virtual world system, and then implement artificial intelligence in the virtual world system. Is that right?
Yeah. So one of the ways that we see AI technologies being incredibly important and useful is to generate narrative-centered learning environments and to support learners in these environments through embodied agents, and to support teachers through teacher orchestration. So we're envisioning that these are immersive virtual worlds that kids will engage in.
And in Eco Journeys, we're particularly interested in using AI to provide adaptive support for the collaborative activities to help students collaborate well together.
Okay, now it makes sense. But I have a kind of question. The next question is about the cost effectiveness. Based on my knowledge, I think it's very difficult. Yeah, the AI is quite important in your research. But about a virtual world, if you create kind of courses on the virtual world, it's quite difficult. Is that right?
Sure.
So your idea probably is not easy to a kind of scalability or the kind of sustainability is quite dead.
So well, I think two ways. One of the things that I see is that most of these ambitious learning practices have not taken off because they are labor intensive. And we think that the kind of work that we're doing in providing adaptive support at both the student and teacher level is exactly what we need to make these environments scalable. But that said, developing the narratives is a challenge. As part of the AI Institute, we're also trying to develop toolkits for both computer scientists and educators to be able to create, if not fully immersive worlds, at least smaller kinds of narrative learning environments that might be more easily developed. We're also hoping that because we can do tailoring of narratives, that we'll be able to adapt these narrative learning environments to different settings, not infinite kinds of adaptation, but I think through a combination of tools and being able to adapt the narratives themselves. But it's going to take some time.
Yeah, I believe it's kind of time consuming to create this kind of environment. Is that right? Okay. So I concern is about your development. So in addition to Eco Journey, how many this kind of course have you developed?
So we are just at the beginning of the AI Institute.
Okay, I see. So it's probably just the only one, but it's quite advanced. Very impressed. And
I would add that our team is working on other narrative-centered learning environments. We have one called Primary AI, which is teaching about AI technologies integrated into life sciences for the younger grades 3, 4, and 5. But I think it's important to recognize both Cindy and I have long worked with the pedagogies of problem-based learning, case-based learning, project-based learning, narrative-centered learning for many years. And all of our early work is paper-based learning environments. Just read a case or read about a situation, and even an inherently complex situation when told as a story is really it can be a lot more meaningful and authentic for learners. So even though, yes, now we're working in a space where there's immersive worlds and lots of AI technologies to leverage, the pedagogies are fundamentally unchanged in terms of how to do this in a learning environment.
Oh, I see. Very good response to my question. Thank you. Very helpful to us. The other question is about the evaluation. Yeah, we're very concerned about how do you know your system or your idea or your AI are really helping teacher and student in learning. Right. What's your methodology about the assessment?
We have a couple of things that we're doing. I mean, we do pre and post tests for the kids, of course. We also do a mix. We do use mixed research methods. So we do quantitative work where it makes sense. We are working on developing stealth assessments in the game themselves. Our research scientist, Osmalina Saleh, and one of the graduate students, Tanner Phillips, are working on developing assessments of collaboration in the game.
Okay.
We also do observational work to identify how things are being implemented. We interview teachers, we interview the learners. So we use a pretty broad range of methods and try to triangulate what we can tell about learning and engagement.
I see. I believe this is just the beginning or the kind of early phase right now of your project. We are expecting that you have that kind of very advanced, that kind of progress in education. I believe IU education is the top one in the world. I believe you have that kind of potential. I'm glad that you bring this kind of very advanced topic to our audience over here. And right now, I believe we have over probably 200 audience in the presentation hall right now, and your presentation is streamlined through the YouTube to the school or to Taiwan right now. I believe several of our alumnus, they also are online watching your presentation. They are a kind of very eager to learn from both of your research. And sorry, I would like to say some Chinese to the audience right now. I ask them to interact with both of you. I know it's kind of late right now in Bloomington, but please, we still have 10 minutes left right now. So 各位观众不知道有什么样的问题，利用这机会跟OK 好要跟他们做一些互动。Please come up here. Okay. Yeah, we have a question from our president of a university over here.
Cindy
Mr.
and Krista, thank you for your presentation. See, I see you're building a collaborative managed engagement environment, and I see there's a conversational agents that's in between. You said you're scaffolding, so you have an individual, group, and class. For three levels of engagement. I'm wondering first, you said it's based on natural language processing. So how do you handle this? How natural or what kind of engine you're building to process this? Second is that suppose you have a group of discussion, and everybody is trying to say something among the groups, and the agent already collects a lot of conversation ideas. Can the agent know that these guys, whatever your discussion is going to the wrong direction, and I should try to correct it? If everything follows by the rules, then there's no AI. I'm trying to say, but you have opposite and positive the ideas. Then I believe the agent, since it is a conversational agent, as a mentor, and also as a facilitator, and can it be that like that? Try to collect the ideas, then get a focus, then see, hey, I should correct it, and you guys better addressing this issue rather than the other issue.
You mean just like a human, huh?
Yeah, I'm not sure, but I'm just curious. Yeah, thank you.
Okay, thank you for your question. Yeah, the President Leo is, I think you are also an AI expert, I believe, in computer science. Yeah, the question, he asked two questions. Do you understand two questions?
Yeah, let me see if we can keep track of them both. In this initial version of Eco Journeys, we're working with log data, and we have various sentence starters and things that are tagged in ways that don't require natural language processing. But our next step is to include that. I am not going to pretend that I understand the technical nuances of it. We're working with experts in natural language processing at University of North Carolina and North Carolina State University and Vanderbilt. the collaboration between education researchers and computer scientists is really important in that. But our hope is that the natural language processing is going to be the next step.
Okay,
I think that the importance of the conversational agents is to help provide the team, because you gave the example, well, what if they're just going completely off base? And what if they are going in a wrong direction? And so the idea of the conversational agent will, yes, be to cue different sets of actions needed to either bring the ideas back into focus or to get on the right track, but also to problematize the learning. Sometimes learners are really satisfied with surface level understanding, and we want them to go deeper in some ways. So the functionality that we're imagining will be, yes, in some cases to maybe ask key questions to help prompt the kinds of discussions and dialogue that surface the main ideas, and to help students to go deeper with the main ideas so that they're not just staying at surface level understanding.
And one important piece of the problem-based learning pedagogy is that we don't tell, that we try to gently guide and scaffold and ask questions. And so sometimes we let things go in a little bit different directions, but being able to understand, how far to let that go is one of the things that is an important piece of orchestration.
Okay, thank you. It's kind of, this is a new project. It's a kind of joint project among several universities. And this is the fourth year, as far as I know. Is that right? It's the only fourth year.
It's the first 3 months.
The first 3 months.
October is the first month.
Okay, so it's early stage. Probably, we in Taiwan here, we have quite a big group of AI experts. Probably we could try to work together. Is that right? Probably we could work together. I believe, it's not easy. What President Leo mentioned about interaction or AI response, it's a kind of just like a human. It's kind of impossible. It's still far away to create that kind of AI intelligence to interact with a student or a teacher. It's probably it's still not easy. But I think it's on the way.
Yeah, I think it's on the way. I think if you invite us back in 5 years, when the project has been going for 5 years, we will have learned a lot about how to leverage these technologies. We will have made a lot of mistakes along the way, and we will be at the edge of things we hadn't yet even imagined were possible as we sit here now.
Okay, sure. Now that's great. That's great. Probably, I would like to tell you, probably we should try to create a kind of a partnership, collaboration between Taiwan and your team. Our national policy, we have that kind of a very, bold, that kind of plan. Probably every student in K-12 level, we all have that kind of devices. In all the students, and we very good that kind of computer network in all the school. So government try to support this kind of digital learning environment, and AI that kind of help scaffolding are quite significant to this kind of the success of this kind of application. So and we are trying to work on that. So that's why we are very kind of glad you present this topic to us today. But really, it would be great if we could work together or collaborate together in the future. But right now, the pandemic, we are not allowed to go to visit your office. Otherwise, we could organize a kind of visiting tour or visiting group to visit your lab or office in the future. Hopefully, the pandemic will go away.
In the future, you're invited anytime.
Okay, that's great. That's great. That's great. So sorry, let's speak Chinese one more time. So 各位老师、各位听众，有没有什么样的问题？利用这机会 想了解一下，他那个也是我们现在正在所急需的，就是一个数位的学习环境，然后把 AI 带进来，他的构想很好，其实他也提到 PBL， 好，这个是我们想做的，然后当然 PBL 真的很难做了，尤其我们现在都在实体的，都在网络上，那更难啊，然后他尤其 interaction， 他想用 AI 去 nurture that kind of interaction， that kind of dialogue between peers， 帮助老师去做管理。我想这个价值是非常重要，非常重要。所以我们希望以后也可以朝这方面去。我这里好像有一个刘教，好像今天都姓刘，人不知道在哪，在后面的样子是。好像今天下午有一个报告，他也是 CSCL 的专家，我不知道他有没有什么问题，或者老师有没有什么样的问题？假如没有问题，我想我们大概时间也差不多了，我们就这样。好 ，OK， probably they couldn't speak fluently in English. Probably we will talk more or try to ask questions by email. So probably I think time is about over. Yeah, thank you for your presentation, one-to-one presentation. Yeah, right now in Bloomington, it probably is already approached 10, and it's cold out there. Christy, you need to go home, right?
Yes.
Go home. And so be careful and have a good sleep. And thank you for your presentation. We are keeping in touch. We are keeping in touch by email.
Okay.
Absolutely. Thank you so
Thank
much
you for inviting us.
Okay, thank you. Happy Christmas. Happy Christmas.
Thank you.
Merry Christmas. Okay, thank you. Thank you very much. Thank you. OK， 我们今天就到这里，谢谢大家，谢谢。
谢谢。
谢谢主持人与主讲人。现在是休息时间，下一场次开始时间是11点10分。 即将开始。邀请国立清林秋斌教授，请。
对，讲林教授，林教授哈，教授 ，OK。And could you hear me? 听得到吗
Hello. Hi, good morning. Good morning.
Oh, at the moment, I have to introduce you.
Yeah, I think there is some kind of broken sound on my side.
Okay.
Yeah. Maybe
Okay.
can you also turn off the audio for the other computer? Yeah.
没关系。Okay. I'm glad to introduce my very good friend in Singapore, Dr. Wenli CHEN. And she is the head of learning science and assessment academic group at the NIE now. And her research focus on CHEL, learning analytics, AI for education, and mobile learning. And she already published more than 80 journal papers. Yeah. So, Wenli, could you hear me?
Yeah.
Okay, so
yes.
That's your time. And we will have some audio from YouTuber. So maybe you can see the YouTube and they will type some question later. Okay, your time.
Sure.
Thank you.
Yeah, thank you. Okay. So thank you for the nice introduction, Professor Robin Lin. Yeah, okay. So a very good morning to all of you. Greetings from Singapore. So thank you for the invitation to speak at this important event. I'm Wenli CHEN from National Institute of Education, Nanyang Technological University. So today my talk title is about learning analytics for learning design. Okay, so first let me share with you what my talk is about. So the background of this. So nowadays, right, there are some kind of challenges in learning design. Yeah, so here is a very famous quote. Throughout the history of education, the adoption of instructional programs and practices has been driven more by ideology, politics, and marketing than by evidence. So now we are calling for evidence and data-driven based learning design. Okay. So on the other hand, let's take a look of the challenges in learning analytics. Yeah. So nowadays, learning analytics become very popular, very hot topic. So we're looking into how analytics can be interpreted, can be applied and acted by teachers. So as a researcher, we can come out of all kinds of learning analytics, right? But there are some kind of problem. Sometimes we need to complete the loop. So what is the loop? We come out a lot of analytics indicators, measurement. However, the practitioners or teachers, they find it difficult to turn this into actionable insights to them about students' learning and which inform their teaching. So here are the two challenges in learning analytics and the learning design. So my talk is about the synergy between these two fields. So how can we do an analytics-driven learning design to enhance our students' learning? So in my talk, I'm going to talk about 40 minutes and followed by about 10 minutes Q&A. So the outline of the talk, first, I think I'm going to talk about what is learning analytics and why learning analytics. Then I'm going to share some of the common types and the techniques of learning analytics and the trends and issues or challenges of learning analytics. Last but not least, so how learning analytics can inform learning design, how learning design can impact learning analytics. Okay, so I had a look of this conference, yesterday's program. I noticed that there are some participants and speakers also presenting research and papers and practice using learning analytics. So I believe learning analytics is not new to many of you. So this is the so-called official definition from SOLA, right? SOLA is the Society for Learning Analytics and Research. So they have come out this very widely used definition of learning analytics. It is about the measurement, collection, analysis, and reporting of data about learners and their learning context for the purpose of understanding and optimizing learning and the environment in which it occurs. So if we further unpack this definition, so how learning analytics works. First, we need to conduct evidence-based and data-driven analytics, right? We analyze the data, monitor students' learning, and predict students' learning outcome later. So by this kind of a systematic way of doing data analysis, we are able to better understand the students' learning experiences and environment, which include both learning outcome and learning process. With this understanding, as the practitioner and also designer of the students' learning experiences, they can optimize students' learning experience and environment by some kind of innovative learning design. Okay, so this is how learning analytics works. Okay, so right here, this is a learning analytics cycle. So first, learner will generate some data, then learning analytics researcher or practitioners, based on the data, we conduct very systematic way of doing data analysis. Then we come up some matrix and the measurement, and this will inform the intervention. So what kind of things can be included in the data for learning analytics? So researchers like to talk about 3 A's: activity, artifact, and association, right? Activity are about what are the students are doing, the things they do, right? Artifact. Sorry for the hiccup. Let me get my slides back. Okay. So artifact is about what are the things have been created by the students. It could be those learning artifacts generated by them. For example, their answers to a particular question, the written explanations of scientific argumentation, or maybe some kind of artifact that they have generated. Right? And the third A is about association. Association is between activity and artifact. Actually, in the most of the learning analytics research, right, the data sources are in these 3 A's. But having said this, learning analytics, the data, actually we can treat it more comprehensively. So sometimes we can also analyze the students' demographic information. This will help answer who are the learners, what's their background, right? And we can also look at their learning performance. Learning performance can be in a pre-test and a post-test, okay? And also the feedback and the perceptions of the students. On top of that, we can also examine physiological data. Physiological data including, nowadays we are using science of learning method to monitor students' learning. It has gone beyond the traditional cognitive data. Yeah, for example, nowadays we are using eye tracking to collect the data on students' eye movement. We are using EEG or apneas or MRI to look at the neuroscience data when students are engaged in a learning activity. We can also do those kinetic sensors to look at the students' motor learning. So there's a large amount of data available nowadays, especially with the rise of the open education and online education. So why are we doing learning analytics? I think the purpose, of course, as a researcher, right, we want to understand the students' learning. But for educators and the learners, they also play a very important role. So first, it will help us monitor the students' learning process and outcome. So for the learners, with the learning analytics data, they are able to compare their own learning with that of others and compare their learning with their learning objectives. With this, they are able to identify their own learning gap and inform any learning strategy. This will also help increase their awareness, reflection, and metacognition of learners' own learning. So on the educator's side, with the learning analytics, they can improve their understanding of their students' learning and identify students' learning difficulties, if any, and identify those opportunities for learning support. So as a teacher, they can also find those early indicators for students' fail or success. They can also assess and improve their learning design. So learning analytics can play an important role in every aspect of students' learning and on teachers' teaching. Okay, so here comes to the types of learning analytics. So the type of learning analytics is classified based on the purpose of this learning analytics. So in general, there are 4 types of learning analytics. So the first one, which is the most basic one, descriptive analytics. So this type of analytics is trying to answer what had happened in students' learning. Yeah. Then the next level will be diagnostic analytics. Diagnostic analytics, the purpose is trying to answer why did it happen, which part students did very well, which part students didn't do it very well. Right? The third type is predictive analytics. So we can use this type of analytics to predict what would happen next. So what would happen could be we are using our learning analytics to identify those at-risk students. At-risk means they might fail if they continue do this type of learning and if they do the learning in this way. So with this kind of information, some of the learning analytics, they are also looking to intervention, which is a prescriptive analytics. So how can we make it happen, or can we prevent it happen? Okay. So allow me to pause 1 second. Let me stop my YouTube, see whether the internet will get better. is my network okay? Shall I continue? Okay. Thank you. Yep. Okay. So just now I have talked about 4 types of learning analytics. Right? So now let's take a look. What are the techniques for this type of learning analytics? The first one is a descriptive. Right?
The signal is not very well. We have to change our network. So maybe we have to wait a moment, 1 minute, okay?
Sure. Network problem. Sure.
等一下哈，因为网络讯号有一点断断续续的哈。Okay, Wenli, could you hear me?
Yeah, I can. Shall I continue? Shall I continue?
Continue. Yes, thank you.
Yeah, thank you, Robin. Okay, let me continue. So now I'm talking about commonly used learning analytics techniques. Yeah. So looks like I'm able to hear some echo from your side. Okay, let me try again. Yeah, I'm able to hear the echo. Okay, so now it's good. So let's continue. So the first techniques I'm talking about learning analytics is descriptive learning analytics. These techniques are using those data aggregation, statistical analysis, and data mining techniques to analyze learning data to understand the students' learning pattern and the trend of learning. I think we are all very familiar with this, right? Using means, standard deviations to present students' learning outcome and process. Okay, for example, in a lot of learning management system, this function, descriptive learning analytics, has been enabled for the teachers and the students. So Blackboard is one of the learning management system which is commonly used in higher education, right? So as you can see, if you go to their course analytics function, go to that module, you are able to see a lot of descriptive learning analytics presented there. Yeah. So in 2017, GVET had done a systematic review of a learning analytics dashboard. So dashboard is a very, very hot now. Dashboard is a type of a graphical user interface which often provides at-a-glance views of learning. So based on this systematic review, there are in general 5 types of dashboard. Cognitive, which is about students' learning performance. Behavior is about students' engagement or uses of those learning content. Emotional is about learners' motivation and affect. And also metacognitive dashboard. Metacognitive dashboard is related to students' knowledge and beliefs and reflecting on their own learning processes and outcome. And last but not least, self-regulation. So self-regulation includes regulating learning with these 5 areas. So the dashboard is one commonly used descriptive learning analytics representations. Here I'm presenting you one of the examples of this metacognitive dashboard. So this research project is done by my colleagues at NRE, Jennifer Dunn. Yeah. So as you can see here, after the online learning activity, this dashboard presented the user their metacognitive information on critical thinking and collaborative learning skills. So the graph, the reader map on the left is about the students' critical thinking. So there are different dimensions, and this graph we're presenting the students of the info, which part they did very well and which part there was still a lot of room for improvement. Likewise, on the right part, right, the right section of this slide, it is about the students' collaborative learning and in 5 dimensions. With this type of dashboard, students are able to identify their strengths and the areas for improvement in terms of their critical thinking and the collaborative learning skills. So this is about metacognitive dashboard. Okay, so the second type of learning analytics is about the diagnostic, right? Diagnostic kind of learning analytics is trying to explain why it happened. So why it happened, we are trying to use analytics to unpack the learning process and provide feedback to the students, which part they did so well and which part they didn't did very well, right? So this is one of the examples from my own research project. So we have this kind of dashboard on students' collaborative argumentation. So this is about scientific argumentation. If the students, they only present a claim, but without any evidence, then it is a green apple. The dashboard will present a green apple to them. Green apple means a bit sour. They need to further improve the argumentation to make it sweeter, right? So once they add one evidence for or against this claim, and the green apple, the color will turn into red, right? If they add one more evidence for or evidence against this claim, it will become orange, and if they add more and more, it becomes golden, right? This is really diagnostic, trying to help students understand where are the gaps. Okay, so some other diagnostic techniques of learning analytics on top of those of cognitive learning, right? Nowadays, researcher is also looking at some kind of structure discovery. So for example, social network analysis. So many dashboards, they have enabled this. This one is also from my own research project. We are using this social network analysis to characterize students' network structure in terms of nodes and the ties. So here, the nodes, the dot, each dot represents a student. The ties and the links between these nodes, actually they are the interactions. So the thicker the line, the link means the more interaction between these two students. If the area of the dot is bigger, which means these people has been contribute a lot to the online discussion, or they are very actively participated in the learning activity. So with this type of social network analysis and the representation, it is very easy for educators and the learners to understand social participation of the learning activity. Right? We are able to understand the patterns of interaction and identify the indicators of learning. Right? Another types of structural discovery is may not be based on the unit of analysis is not on people, not a person, but could be the idea, the meaning, right? So one such example is ENA, epistemic network analysis. So this kind of analysis, we are trying to model the co-occurrence of different concepts and elements in the learning process. So here, as you can see, this is also from my own research project. We analyze the students' pre-test and the post-test essay, is argumentative essay, right? Then we found in the pre-test, the meaning and the concepts presented, the number, yes, there were a lot of concepts and the meanings presented in the pre-test. However, the relationship are very, very weak. But after our learning activity, as you can see, actually those ideas become well linked and connected with each other. So with this type of structural discovery, we are able to identify the relationships among those meanings or ideas in students' generated artifact. So this kind of a technique is really help with diagnostic learning analytics. It will help us understand how well a student's doing rather than just presenting a single marks, say pre-test to post-test. Now they improve from 70 to 90. So the improvement is very significant, right? That's the traditional way of doing learning analytics. It is not enough because that is still descriptive. It is not diagnostic. So with the new techniques in terms of structural discovering, we are able to tell how did they do, so why they did so well. Yeah. Some other types of diagnostic learning analytics, including some temporally analytics. So temporally analytics is looking into the common order or flow of events. One such example is a lag sequential analysis. We are trying to analyze the sequential dependency in a serially sequenced series of events. So the graph here is from my project. We are looking at the event dependency. So when event 1 happens, most likely event 2 will follow this event 1. So we like to compare students who did very well and who did not very well using this type of lag sequential analysis. And through the comparison, we are able to identify what kind of learning strategy is more effective. So how can we get those information on learning strategy? It is through this kind of a lag sequential analysis. We are able to tell normally students do what things first, followed by what, right? And this may make their learning very effective. Then this one is an effective learning strategy. Okay, so here are two other examples. Visual analytics, right? Visual analytics. The example on the left is a heat map. The data is eye movement data. So we are using different colors. If those things are turned into red means a lot of students are watching here for a longer period of time, right? And it is, yellow color is a medium level of attention, and the green color is a least level of attention. The white color means students didn't pay attention to those, white area. So with this kind of information, we are able to tell how students are engaged with our e-learning design, right? So it could be used in our, course materials design, online instructional video design, and maybe some other learning resources, online learning resources. We want to see how students are interacting with those kind of learning resources, and we can use the heat map and some other techniques, including the Sankey diagram, right? So this type of visual analytics can make learning analytics more accessible, understandable, and usable to a broad audience. Okay, so some other techniques, nowadays researchers very advanced in AI, right? They are using text mining, natural language processing, or machine learning techniques to do the diagnostic learning analytics. Here I'm presenting you one example. This is from Australian researchers group, right? They are using machine learning, machine annotated writing analytics to identify the rhetorical moves. So students can upload their writings into their platform, and this platform will automatically identify those rhetorical moves. They can do some automatic analytics. For example, this sentence, you are likely indicating a gap. Yeah. This sentence looks like you are trying to highlighting a pattern. Actually, these are all feedbacks provided by the machine. Okay, so the next level, predictive learning analytics. This one will help us understand and forecast the future, right? There are nowadays a lot of researchers in MOOC context. Actually, they are doing this type of predictive learning analytics. Those researchers, they like to link the students' engagement data with their final marks of the MOOC courses. And they are trying to predict what type of learning engagement will predict success of the students. Right? And many other researchers, they also make use of the learning management system data. And so far, they are very, very reliable. For example, McFadden and Dawson's research, right? They are able to use learning management system data to correctly identify 81% of the students who failed the course, right? So they are able to identify the at-risk students. Okay, here is another example. Gillen used the process mining, right? They compare students' behaviors of successful and less successful students, and they are able to identify effective learning strategies. So usually they are going to classify students with those who are very successful in their final marks, and the other group of students who are less successful. Then the researchers go back to analyze their learning analytics data, trying to identify the patterns of students' learning. And the finding is what types of learning behavior will predict their fail or success at the end of the course. Some of the techniques in the predictive learning analytics, classification, decision trees. This is commonly used in early alert system and some of the adaptive learning system. So due to the time constraint, I won't talk about the details of those techniques, right? So the last but not least, I'm talking about the prescriptive learning analytics. So prescriptive learning analytics means on top of the predictive learning analytics, this system will also provide some kind of intervention. They can detect those at-risk students and provide some sort of intervention. The intervention could be more learning resources and suggest some optimized pathway of the students. Right? This is a prescriptive learning analytics. Okay, some of the emerging trend in learning analytics. So emerging trend, yeah. So nowadays, what we are looking into is not just the learning outcome, but real-time, moment-by-moment learning analytics. And the researchers is also looking to those non-cognitive processes and outcomes, which include motor learning, motivation, emotion, social emotional lifelong learning skills, and also multimodal learning analytics. Yeah, multimodal learning, my research team is looking to this area. How are we going to integrate various data streams to holistically understand how people learn, right? So now we do have the behavior data, online behavior data, and the log file, but now we are also trying to use eye tracking and apneas, trying to look at the oxygen level, bring oxygen, see which part of students are more engaged and which part of the learning activity they are less engaged. Some of the emerging trend. Okay, so having said this, now I'm looking to the relationship between learning analytics and the learning design, right? So if we have talked about a lot of techniques, nowadays a lot of researchers, they like to use data mining approaches. Data mining means sometimes we don't have a clear theory to guide the learning analytics. We just let the machine run, right? So see what are we going to get. But having said this, this kind of approach has its pros and constraints, right? And sometimes those data mining approach, the result they generated, we do not quite understand what is going on, right? So that's why we are arguing more meaningful learning analytics needs learning design perspective, right? Okay, so here comes to the learning design. Yeah, so I'm not going to talk about those literature, yeah, in very deep. Just share with you nowadays in the learning sciences, what we are looking to is educators. They need to be the learning designers. We need to be the learning designers. We need to be the designers of students' learning experiences and environment. So this kind of things will inform our learning analytics. So with those learning design knowledge, we can have a better learning analytics. So that's the key argument of my talk. So let's take a look. This is a model of learning analytics, but now let's build into learning design. So first, we need to understand who are our learners and what kind of data they are generating and we do some analysis. We do some analysis on their student-generated data. Then we will inform our design and intervention. Okay. So as you can see, this is a learning analytics informed learning design model. Yeah. This model, as you can see here, learning analytics plays a role in every component of this learning design, including tools, activities, content, sequencing, groups, and assessment. So once the teachers are designing the learning activities, they keep in mind what are those behavior data generated by the student. It could be students' behavior data, could be instructors' behavior data, and how this kind of a learning process, learning activity will affect the students' performance. And we also need to be clear what kind of a data which can help us understand the students' performance. And all those data will help us answer all those questions about our learning design. And this, we are able to provide feedback to the learning designer and instructor. So as you can see here, with now learning design and the learning analytics, they are intertwined in both learning design and learning analytics approach. We need to integrate them. Okay, so let's take a look at how learning analytics can inform the learning design using this ADDIE model, which is a famous model for instructional design. We are putting the learning at the heart of the design process. So first, we need to analyze who are the learners, what do they learn, how it will be measured, right? So we like to do the profile analysis, profile of the students' demographic data, background data. Then the next, we need to look into what are the learning outcomes that students are going to demonstrate in both the learning process and the learning outcome. So as a learning designer, we need to be clear if we want students to achieve those learning outcomes, they need to do what? What are those behavior terms and how they will be measured? Then we need to think in the process of the learning design, what kind of data and what kind of questions we want to answer by those type of data analytics. So we like to use this 5P model, okay? So first, point. Point means what does a good learning design look like? Second P, process. What are the elements in the learning design and how do learners engage with this element? This is about analytics on students' learning process. The third P, proxy. Proxy, what outcomes and analytics indicators does the learning design provide? This one is about operationalization of the learning, right? So how do we know? How are we going to measure students' learning? The fourth P, plan. How do we collect and analyze the data? Then the last P, payoff. How to identify elements that worked or did not work well, how the learning analytics result help improve the design. So as a learning designer, we need to keep in mind, we need to have the data for all those 5 Ps and we know how to do it. Yeah. And for the learning analytics, we also need to see it need to be driven by this kind of learning design questions. Then we are able to provide a more meaningful and actionable insight for learning design. Okay, so here I'm sharing with you some of the examples. So some of this is in a MOOC design, right? So just now I share with you, so as a learning analytics researcher, it need to be guided by our learning design. Here is one of the examples by Keynote's framework. In MOOC, he classified, so what are those meaningful activities in MOOC, right? And he defined it. He classified 6 types of important learning activity: delivered content, reflection, collaboration, conversation, browsing, and assessment. Then he further operationalized what kind of a learning behavior is falling to this category. For example, in terms of delivered content, research can look into students' reading behavior, watching behavior, listening behavior, or observing behavior. Then they can further identify what kind of analytics from the log file or from students' learning process data we are able to have some kind of indicators of this type of learning activity. For example, the amount of the content viewed or dwell time, right? So here is just a one example with this kind of information, right? So why do we want to have this kind of information? So first, how did the designer expect the learners to engage in the activities? And we are trying to produce some analytics on how did the learners actually engage in these activities. Then through the gap analysis, we are able to identify some kind of insights for our learning design, right? Sometimes the students, if we found that there's a huge gap normally means a few things. First, our learning materials is very dry, not very interesting. So students, they didn't want to do it. Or maybe the difficulty level is too difficult. We need to make them more interesting and engaging and appealing to the students. Or sometimes maybe the learning activities is not very, very interactive. So through this type of learning analytics, it will inform our better learning design. So some other examples, this is from UK, right? Open University Learning Design Initiative. It is also in the MOOC context. So it's quite similar with the Keynote framework, but now they have a different indicators. So they have they classify the meaningful learning activities in this course as assimilative, finding and handling information, communication, productive, experiential, assessment, interactive, adaptive. Then they analyze what is the optimized engagement level and what is the actual level of the students' learning engagement, identify the gap, and those gap analysis will present findings to inform a better learning design. Okay, so this is a Nancy Lau's framework on learning activity taxonomy. So I'm sharing with you a few very well-known taxonomy of learning activity, especially in the online education context. So if you are interested, you can read their papers. They present very details, a lot of details on why they think those are important indicators for students' learning and engagement, and how it will be measured in the online education scenarios, and what kind of data are they collecting and how it will be analyzed. Okay, so to conclude, learning analytics helps identify, learning design can help us identify useful learning analytics or gap of learning analytics and guide our interpretation, application, and action of learning analytics. Yeah. Learning analytics cannot be used effectively without the understanding of the underlying learning design. Yeah. Learning analytics helps validate and inform the pedagogical decisions in learning design. So that's why learning design also need learning analytics for evidence or data-driven decision making. They need to come together to empower reflective practices, and it will help promote a participatory culture of design and analytics. So therefore, data analytics and the learning scientists, they really need to work very closely, which will help them come up with a better learning design and a better learning analytics. So that's the end of my presentation. Thank you very much. Sorry, I'm not able to hear anything from the conference venue. It's muted. I think your side is your side. Okay. Thank you.
So it's Q&A, and sure. You can ask a question in Chinese. Any question? The audience from YouTube, they can also ask a question.
Okay.
Any question? 校长有没有什么问题？好，林老师来。
Yeah, hi, Wenli. Nice talk. Yeah, it's a very good kind of knowledge or trade in LA. Actually, I'm also doing that, but based on my knowledge, yeah, I focus on K-12 level. I just wondering, do you have any kind of example for application so far in K-12 level? Because I know most of the application or most of publication in LA field, they are all related to higher education, especially with MOOC. How did you find the kind of application in K-12 level? Do you have any kind of example?
Yeah, thank you, Prof, for this question. You're right. Yeah, you're right. If we take a look at the literature, most of the learning analytics studies are conducted in the university context. But having said this, there are a lot of learning analytics research in K-12 as well. Actually, today, what I shared, my own project examples are all from K-12 context. For example, collaborative argumentation. I also share one example on metacognitive dashboard on critical thinking and collaborative learning. That dashboard was used in secondary school. So my project looks apple, different color of apple. It was in the higher primary, which is a grade 5 and 6, and the lower secondary, which is secondary 1 and secondary 2. Yeah. So we do have a lot of learning analytics systems used in K-12 context. And nowadays, there was a government initiative. All the government school students, they need to use an offline learning system, which is called Students Learning Space. That system was initiated by the Ministry of Education. So the huge amount of the data produced in that system. So the researchers and the policymakers, we are working together how we make those data analytics more insightful for the designers. So I think the work is in the pipeline. Sorry, it's muted again. I'm not able to hear.
Do you hear me? What I try to say is thank you for your response. It's wonderful. I'm glad to know you have done a lot of research in this field, especially in the K-12 level. So I would like to read about your publication.
Yeah, thank you so much. Yeah, we can
ask.
Yes. Yeah.
Okay, I'll ask help from Dr. Lee over here. Okay.
Yeah.
Thank
you.
Thank you.
Sure. Thank you.
Okay, thank you, Wenli. We still have a last question from YouTube. Could you see the question from YouTube?
No, not yet. Just now for a better internet connection, I disabled.
Question. The LA development now need time to process. How fast could you provide the information of LA to teachers at this moment? Did you hear?
Yeah, so I think the question is about whether the learning analytics is real time. Yeah. So this is a very good question. I would say excellent question. This is another dilemma learning analytics researchers are facing. Sometimes we come out with very fancy learning analytics, but it only come out at the end of the learning activity. Sometimes far behind what teachers can So that's one. Nowadays we are looking at real-time learning analytics. That is a future trend for learning analytics. Today, the example I shared, my own project and my colleagues' project on metacognitive dashboard. Actually, the dashboard, they are real-time. So students and the teachers, they are able to have a view of those analytics in real time. Some of our prescriptive learning analytics we are providing real-time intervention. So students no need to wait until a few hours later to see the result of analytics. So this is the purpose. To provide actionable insight.
Thank you for your response. So any other question? No? So it's time for lunch. Thanks for your speech. And I will show you my lunch box later.
Okay. Yeah, enjoy your lunch.
Yourself. Yeah. Okay, thank you, Wenli.
Thank you, Professor Robin Lin. Thank you, the colleagues and audience of this event. Please enjoy your lunch. Wish you a successful and fruitful conference.
Okay, bye.
Bye bye.
好，谢谢大家哈。好，那因为接下来的时间哈，我们其实楼下12点到12点半还有大概9个学校在摆摊位哈。如果大家有时间，可以先看一下，因为他们大概12点半要撤场哈。那有很多小朋友他们是从苗栗来的哈，然后也许可以去看一下。那甚至还有学校是从台东来的哈，麻烦各位可以去看一下楼下那个台东三和国小，那个真的大老远跑来，那也可以问问他们这些小朋友，他们也许有一些问题哈，那你可以看看他们的一些回应哈。那不急着吃饭了哈，我们12点半再吃饭没关系哈。好，谢谢大家。
谢谢主持人与主讲人。现在是午餐时间，用餐地点在本。